should probably do an app. Okay.
Yeah, because I hear you. I hear you twice over.
Just. Oh wait, everyone is muted. Everyone's at the workshop. So it.
Yeah.
Okay.
Kind of music.
Old music. It's gotta be. Is it DMCA free or whatever? You know, legal.
It sounds like it's in the way in the distance sometimes.
Just got off work too, dang.
If no one, I mean, we might as well just change the date.
What do you mean?
Save this workshop for later on.
Hmm?
Wait, are you guys saying something right now? I can't hear you.
Hello? Hello? Earth to Alex?
I love EGaDS. I love EGaDS. I love EGaDS.
Alex is
tomato soup.
Okay, it's better now. Cool.
Well, are you recording the thing?
Yep, we should be live, right? Or y'all should be live.
Oh, okay. Well, we can. If you do the workshop, you can make it a video and then post it on YouTube.
Yeah, that sounds good.
Or
I'm loading Unity right now. It's taking forever. I don't know why the new version of Unity, it literally takes a year and a half to open a project. It used to be like a good half a year, but it's 3 times slower now. I don't know what's up. What they did.
Okay, I guess let's start then. So this workshop is going to be over Unity events and making a state machine. And you may have heard those words before and just not really known what they actually are, but that's what we're going to be talking about today. So a couple things that we need to do during this workshop. We need to go over what enums are, just in case anybody doesn't know what that is. We'll talk about what constitutes a state machine, and we'll talk about how to use Unity events. So enums. Enums are basically just ints that assign names to each value. So if you look here, I define a public enum state, and this state can be either idle, jumping, or running. I set the values here, which is something you can do with enums, but the values that are there are just what those would naturally be, because the values are assigned in order. So the first one, idle, is the first one that's defined, so it would naturally be 0. Same with jumping and running. And then once I've defined that enum, I actually want to have an instance of that enum. So I define a state. State down here, and this is just another example. Okay, I'm gonna assume that everybody has a good understanding of enums here. Yeah, because I can't really do anything else. Okay, so state machines, what is it? Well, state machines kind of refers to having an object be described as just being in different states. And the way I word it here, discrete states, that means that one state is completely different from the other. Like you don't want to have any you don't want one state to like also mostly describe another state. You want them to be different in some way. And state machines are really easy to implement with enums, because if you make an enum for a state, well, now you just have a bunch of values that you can call different state names, and you'll be able to define like behavior with those states pretty easily. And ultimately, state machines are really useful because you can use one state. You can like you can check one variable, your state that your object currently is in, instead of having a bunch of other variables that you need to all check together to actually like get the correct behavior. So this picture you may recognize from a certain open world yandere simulator game.
Bruh, you did it. I just want to know why he put male equivalent to false instead of exclamation mark male.
Yeah. Yeah, so like even here, there's only like 2 booleans. There's pretty much only 2 booleans, but it already looks like a complete mess. And that's something we're going to be able to avoid using state machines. Okay, and Unity events. So the 3 main reasons why you would want to use Unity events are readability, efficiency, and encapsulation. You'll see this more when we actually start working with it, but Unity events look really clean. It's a lot different from like putting something in your update loop and just checking it every single frame. It's like it just looks a lot better, pretty much. For efficiency, the same thing. You're not checking something every single frame inside your update loop. Rather, you're just gonna know when you need to call something. And encapsulation it just means that you'll be able to make your behaviors make more sense. So like, if I wanted to call the def function of one object from another, it'd be kind of weird to do it from a different object. Say I was Mario and there was a timer and the timer ran out and now I need to kill Mario. Well, I don't want the timer script to reach into the player controller script and like grab the def function from there and then call it inside the timer script like that. Why would the timer be killing Mario? The timer doesn't have hands or something. I don't know. Maybe it does, but ultimately that's not really the sort of behavior that makes sense. What we really want is for the player script to recognize when the timer is ended, and once that happens, then you die. But again, with the other 2 points, we don't want to just be checking every single frame, and that's why we use Unity events. Okay, so we're actually going to start going into Unity and programming. This is a link to a Unity package that you'll need for this workshop. You just go to that link, download the package, and I'll show you how to install it once we actually start going into Unity. Let me put the link in Oh wait, I didn't do it. Yeah. Boom. Okay, so if you go to this link, you're just gonna want to download this. Downloads. And then you can open Unity. Create a new project. Workshop. Just do that here. Okay. How have you guys been? How was your week? How's everybody been?
Good.
Pretty good.
But also bad because Unity's being a poo-poo because of some layout information stuff that I've been trying to fix, and it's not fixing. It's really annoying. But yeah.
Sounds bad.
That bar is not moving.
Yeah, it really isn't.
I'm
Oh,
telling you, the
no.
new Unity just takes literally forever, dude.
Yeah, it's so slow. You guys want to play a game of Among Us while we're waiting? Oh, no. Never mind.
Yikes.
The
Come
bar
on,
heard
Unity,
that.
I ain't bad. Like, oh, you don't have faith in me?
Yeah.
I'm so pissed off at Unity. Come on. You have to delete.
Unity 2020 does seem to have a couple of big issues. But maybe it's worth it for that dark thing.
Yeah.
Maybe
Kinda
they
is worth it for the dark
because
thing,
they were like,
yeah.
wow, this is really broken. What can we do to make them less angry? Free dark theme.
Wow.
I mean, it worked, right? Everybody was excited about Unity 2020.
Yeah. Real cool. Real cool of them.
Marketing strategy. Okay, looks like it's done. Nice. Okay, so once you have your project open, you're gonna wanna drag this Unity package into the project window. So I'm gonna do that. And it should bring up this window. I'm probably gonna wait a little bit just in case somebody else is still downloading. Actually, just let me know right now if you're still downloading something.
Well, I'm trying to figure out my issue here, but you know, other than so I can actually load Unity.
Right. Yeah, that's fine. Wait, so what is Genshin Impact?
Breath of the Wild clone.
Oh, really?
No.
Not that much of a clone.
It's
but it does
basically
have
a
lot of
meme at this point.
inspiration.
Is it like actually fun though? Is it
I
good?
would know.
If you enjoyed Breath of the Wild, then yes.
Really? Huh.
I mean, it's free. You might as well play it.
Is there like resource
Like what?
like resource?
It's a gotcha game. That's how
Yeah,
they
it's a
make
gacha
money.
game.
It's a
Yeah, but
gacha
like
game.
if you're talking about Breath of the Wild, it's not like any sort of gotcha
Yeah,
that I've
see,
heard in
that's
the
where I
past.
kind of find myself confused.
Yeah,
I downloaded the launcher and then I saw how big the game was and like I don't care to actually install it because
nice.
I don't want to waste my space.
Yeah, it seems interesting. I think I'm gonna go ahead and keep moving.
Add data roaming.
You drag the package into your project window. It brings up this window, and then you're gonna want to import everything. So pretty much that's gonna bring all the assets that we need into the project. Whoa, look at that. And the other thing that we need to do is we need to click on the input manager, go into this corner with the kind of sliders icon. And we're going to want to double click our input manager. And that's just going to put all the settings inside of this object into our current project. So, and we want to do the same thing with the tag manager. So this will ensure that we have our correct layers and stuff. Okay, so now that we have those in, let's try looking at what we have in the scene right now. Okay, so yeah, Mario. But yeah, it's just
Mario.
Mario. But it's lame and it's stupid. Look at this guy. He doesn't even have any animations.
Sorry, where did you drag your input manager and tag manager?
Okay, so you can just click on them and go to this slider icon up at the right, and then you can double click on the input manager and the tag manager, and that'll import any of the any of those settings. Okay, so right now this scene is super basic. It's just stationary Mario jumping around. Look at this lame guy. He can't even crouch or anything. He doesn't have any animations. So obviously we want to change that. Oh.
I don't have a Mario in mine.
Wait, you don't have a Mario in yours?
Nope.
Also, I don't know what this is. Okay.
I just have the level with no Mario inside.
Mario
I have
missing.
a Mario game object, but he's invisible.
Ah, dang it, it did not work.
Is his sorting layer not set?
Yeah, it might be that.
Oh yeah, it's an unknown sorting layer. I don't know why that's the case.
What?
I fixed it, but yeah, it was unknown sorting layer. So whatever that's about.
Yeah, that's weird. Okay, well, if you...
Yeah, I just said it.
So weird. I guess it didn't import it correctly. All right, well, if you do use this package, you're gonna want to make another sorting layer for the player so they can put Mario definitely above the background. Okay, so we have this basic player controller, but we want to start actually adding stuff to it. So let's open our C# Visual Studio IDE, whatever IDE you're using, and let's start adding stuff. So we're going to be working mostly inside the player controller for our state machine, and we're going to use the timer later to talk about event systems. Okay, so as you see, kind of messy, all of the basic movement stuff. So the first thing that I want to do is I want to make it so that the sprite flips when you're walking the other direction. so that you're not just like walking backwards at any time. So the first thing that we should do is probably delete this. that's the only way to suppress an error. First thing that we're gonna do is define an enum. So let's make a private enum, and let's just call it facing direction, or facing dir. And we're just gonna have a left and right here. Okay, so like obviously this could probably be done with a Boolean, but I wanna like kind of display how enums would be used. Okay, so now that we have defined that facing direction enum, we want to actually make an instance of it. So we want to do private, make a facing dir, and we want to, let's just call it dir. Why not? Really? Oh, it's because it's private. Okay, I'm just gonna get rid of that. Okay, so now that we have an instance of that facing dir, actually we're gonna want to make that start as facing dir dot right, because if you remember from the project, Mario starts off facing right, so we want that to be the starting value. Okay, so what are the conditions for Mario to flip? Well, if he's moving left, but his facing dir is right, well, we want him to flip. And the same thing for if he's facing left and he's moving right. So let's just do a really basic function to do that. Let's call it void flip sprite. And yeah, so let's just say if the rigid body velocity dot x, so that's the horizontal velocity, is greater than 0. So if you're moving right and your direction that you're facing is equal to left, well, then we want to flip the script. We want to flip Mario. Let's just do that by making the x transform multiplied by -1. So we want to make local scale. You want to store a reference to the local scale, vector 3. We'll call it new scale.
Hi, Alex.
Hey, Matt.
I had to do dishes and late.
Oh, nice. Okay.
Making Mario.
Yeah, right now we're just making Mario.
Cool.
With a state machine. Wow. Okay, so for this new scale, you're going to want to store a reference to it and then change its x to be multiplied by -1. So that's going to flip the sprite horizontally. And we're also going to want to update the facing direction. So now it's going to be facing right. Yeah. Okay. And then we'll have an else if, and with just the opposite conditions. So left if you're facing right. Copy paste code because I'm efficient. Okay. And now we want to call that in our.
Wait, do you want to set the direction back to the transform?
Oh, you're right. Okay. Transform. Okay, so that should flip the sprite. Jesus. All right, and we'll put that function instead of update, just because. Why not? And let's see if that works. Oh. Yeah, now we got a flipping Mario. Okay, you do also, you'll probably notice that I don't turn around immediately. The turning is based on the velocity that you're moving at. So it takes a while before I actually turn, based on when I'm like changing what direction I'm holding down. Yeah, and that'll be useful later on when we're adding more functionality to the animations. Okay, so that's an introduction to Enums and how to kind of use those as a state. Let's start to actually implement a more complicated state machine for the rest of Mario's moveset. Okay, so we're going to want to have another enum to define the player state. And this should include every single action that Mario can do. So let's say idle is your default, and then jumping. And then you also want to be able to run, so running. And for now, let's just keep it at those three. And we're also going to want to have a instance of that enum. So player state, state. Cool. Okay, and now we're going to want to actually update this whenever our state changes. So let's go down into our do movement. Wait, actually, I didn't put this there. Okay, so we want state to reflect pretty much exactly what the player is doing at the moment. And we want jumping to kind of take precedence over running, because when you're in the air, you can't really tell if you're running or not. So it doesn't really matter. So so let's put an else on this statement. If your horizontal input is not 0, that means you're running. So state would equal running. Okay. And then let's put another if here. If can jump is false, that means that you are you're in the air. So then you want your state to be equal to jumping. And this is okay to have both of these run at the same time because you want jump to be taking precedence over running. So even if you are running here, if you're jumping here too, then you want to kind of override it. And now we want somewhere where we set the player as being to idle. And it looks like we can probably do that in here. So if the player is not running, we can make it into state equals idle. And this is okay because you can only, it's only possible to be in either idle or running. Because on the ground, you can only be in those two states. But it's possible it's also not possible for you to be in idle and jumping. So all of these states are completely separate. And based on this logic, we make this state perfectly reflect exactly what Mario is doing at any given time. So right now, there's not much point to like actually seeing it in action, right? Because we don't actually link that enum to any sort of animation for Mario as a character. But something that we can do is I already set up an animator. And this is a really unconventional animator. Pretty much all I do is from any state, I make a transition to each one of these animations. And I only have one parameter. And that parameter is an int called state. And based on the value of state, it will go into a different animation. So if state is equal to 1, the Mario jump animation will play. If state is equal to 2, the Mario run animation will play. And pretty much what we can do now is, since we have an enum that describes the state, and we have an animator that takes in an int and goes to a corresponding animation, we can almost just make our state parameter in our animator equal to our state enum in our code. So we already store in reference to the animator right here. So instead of update, all we're gonna do is write enum.set integer. We're gonna change state, and we want it to equal the state that we have in here. And it's gonna say you can't make an enum into an int, but something we can do is just cast it into an int. Okay, so yeah. So now, usually setting up animations inside your code is kind of a pain, especially if it's a really complicated animated controller. But if you're using a state machine, it's a little better because if you know that your state machine is correct, you can just do something like this, and your animator is like, your animator is pretty much already a state machine. So if you make a state machine in your code, it's a lot easier to translate it into the animator state machine. Okay, so let's see what that did. Okay, so jump animation, nice. Run animation, nice. Okay, and that's with me only adding that one line of code. Okay, and let me explain a little bit more about how this animator works. So I have the state equaling 0 transition into the idle, and state equaling 1 transition into jump. And an important detail is you either need to set the values of your enums to be corresponding to what you do in your animator, or you need to order them correctly, like how I did here. So idle is naturally equal to 0, jumping is naturally equal to 1, running is naturally equal to 2, and that's the same as how they are inside of my animator. So yeah, that is one advantage of state machines. You're able to get your animation working pretty quickly. And if you're actually going to be doing some specific logic with your state, it's going to be a lot easier. So I guess I will take questions before we move on to the next section of this, which would be UnityEvents. Is there anything that was confusing? Are you lost on anything? Is there anything that you want me to explain more deeply? You can't break the blocks.
Here, I have a question. I don't know if you know the answer to, but like, it's kind of just an educational question because I already know the answer as well. But it's like a Turing question if you're familiar with the phrase. What if I want my character to have multiple states at the same time?
Right. So something you can do is define 2 enums, and one would be all the base behaviors that your character should be able to do, and the other one would be specific to the kind of action that you want to have multiple states. Because like, say you're playing Mega Man, and Mega Man can run and shoot at the same time. But you also don't want to define 2 different states for running and shooting. So instead you just have running be in its own enum, and you have another enum that describes not shooting and shooting. And with those, you can kind of, you can get slightly more complicated behavior.
So, I mean, that's definitely true for that scenario. What I was trying to point out is that there's sometimes cases where you can have multiple states in the list of states that you're existing. So like right now you have idle, jumping, and running, and maybe there's like sliding, or you could probably be like running and sliding at the same time. I don't know. But if that type of situation does come up and you want to treat it more like a flag, something you can do is you can make your enums powers of 2, and then use the or flag or the and flag or operator on your enum, and they can exist together as part of each other. So
okay.
So you can override the default int value assigned to your enum by doing an equals. So like idle equals value. So like what you would do is like idle equals 0, jumping equals 1, and then running or equals 1 shifted over by 1 byte, and so on. And that way you have powers of 2s.
2, okay.
And
then you would have maybe a 4th state where it's like crouch, and this would crouch, and this would equal 4.
Yeah, you can actually just, what I would do is do one shifted over. You can do the bit shift operator. That way it's still incrementing by one. So it's like making sense. You don't have to do the mental math. So I would keep 0, then one shifted by 1. Or I see what a lot of people do is 1 shifted over by 0, 1 shifted over by 1, and so on and so forth. Yeah.
Something like this.
Yeah, exactly.
Okay.
And then there's also a descriptor in default C# called flag that you can put on enums like this. And it's just a flag to like mark them, and also it'll make their two strings show up as flags.
Oh.
But that's just a little bit advanced for anybody who's interested in doing something like that.
So some of the OpenGL functions work like that with bit fields. Another common way to do it is to specify them in hex, so the math is easier. Yeah, that makes sense. Huh. Okay. So when I want to set the state to something like so
like instead of just running, you can do running and jumping, right? So you could do you would just instead of like what you're doing now is you're doing an overall assignment, you can do an or equals.
Okay.
And then it would match with every single one that it actually matches to. So like started with 0 at the beginning of
like
the start move, and then or equals.
Wait, is it like this?
Yeah, exactly.
Okay. So if it is idle or crouch at that point, it would also just be run, or yeah, it would also have running. Okay. Yeah, I didn't know that. That's interesting. Let's not do that for this workshop though.
I agree. It's a particular use case, not
Yeah,
this one.
It's kind of a lot, and we would need to build around it a little. Okay. Also, I see in the chat to add state I to your current state, you can do current state or equals, and then the enum value. And then you would remove it by doing and equals the negation of the enum value.
I mean, yes, but no. Like it would work with booleans, but like you could only do 2. So what's the point?
Yeah. And the point is to just like avoid using a lot of booleans to describe behavior in the first place. So you usually wouldn't be wanting to touch bools that much. Okay, so let's go on and talk about Unity events. Okay, so here's the timer script, very simple. Also using the enum knowledge that we just learned. So it has 3 states: stopped, running, done. I don't think I actually used the stopped state. It's just there for like description. And the way this works is it has a time limit. If the state of the timer is running, then it calls this function. This function subtracts time from the time limit. Obviously, this would like actually change that value, and then you want to be able to reuse this timer, but we don't really care about that right now. Just don't do that if you want to actually make a timer. And if the timer drops below 0, then you want to call a different function called time up. And this will print to the console and will change your state. So your state will now be done, and then the timer will stop running. Okay, yeah, so pretty simple timer. And this could be useful for like how most Mario levels have a time limit. And once that time limit runs out, Mario dies. So how do we want to actually go about doing that? Well, we did see that in the player controller, we had a function for die, right? So one option is to either have a public reference to the player, or like actually just find it game object dot find player, and then you get the component of the player controller on it, and then you call die from here. But wow, no, that's terrible. That's like so many functions and just like so many assumptions that you definitely do not want to do that. And also die isn't even a public method, so you can't actually call it once you've done all of this other crap. Ultimately, that's just not what you want to be doing. A different, better way of doing this is by using UnityEvents. So the basic idea with UnityEvents is you can define an event, and you can store a reference to that event, like on a script or something. And whenever you have something happen in one script that you want another script to like recognize, you invoke that event. So it looks something like invoke, kind of like that. And what that would do is it would tell all the scripts that currently hold a listener for that event that, oh, that event has happened. Now do whatever you need to do that relates to that event. Yeah, that might not make complete sense. So let's just get into an example. So for this timer, let me bring up my notes. If for some reason you're worried about memory size with your enum, you can also assign the base type to byte. I'm not really sure what that means.
I was just thinking about him asking about bool earlier. And you can change the type from int to byte if you want.
So there are just fewer available values.
Yeah. But I mean, honestly, you rarely ever use more than like 5.
Right. Okay. All right. So to use UnityEvents, you're gonna have to include the library. Oh, is it Unity? I think it's just Unity. Events. Wait, where is it? Oh, okay. So Unity Engine events. And that's going to allow you to use the Unity event class. So the first thing that we're going to want to do is public Unity event. And let's call this on timer finish. Okay, so we've created an event. And anything that makes a listener for this event will be able to know when it's invoked. So when do we want to invoke that event? Well, once time is up, we want everybody to know that it is up. So for that event, on timer finish, we say invoke. All right, nice. All right, let's go back to the player controller. And we're gonna need a reference. Wait, I make this public, right? Okay, there are 2 ways to do this. If you go back into your code and I actually add a timer into the scene. So I'll pause the timer. So since it's public, I can actually change it. And you can see that it actually has this UI here. And you can add stuff to it. And it gives you all this stuff. And pretty pretty much how you use this is you drag an object that you want to call a method from into this field. You select the script that you want the method to call from. And you would select which method you want to call. So one method of doing this is to make a public function. So I would make it public. And it's refreshing. You would make it public, you would go into the script that it's in, and then you would select it. So now, anytime that this timer finishes, it's going to call the function. Let's actually make this time limit shorter. Let's make 3 seconds. And let's see if that worked. 1, 2, 3. Nope. That did not work. What did I do then? Wait, is it just? Yeah, I don't know why that's not working. Maybe it's just. Maybe this public Unity, the public way of doing it isn't exactly what I thought it was. Yeah, because it should have already killed Mario. Yeah, that's weird. Well, forget what I said about that then. I'm gonna make die back into a private function. And I guess we're just not gonna be using that public stuff. So I'm gonna do a hide in inspector. So that's gonna make it so that all of this does not show up anymore. Yep.
That should have worked, I think. I don't know what the issue was.
Yeah, it should have, right? But I don't know why it didn't. Okay. Well, here's the other way of doing it that I know works. So first of all, you're gonna want to get a reference to this on timer finish. So inside of our player controller, let's just say we have a public game object. No, public.
I think your timer's never ending.
Oh, really?
Yeah, because Time's Up has a print on it, and I didn't get the print.
Really? Huh.
Did you get the print on yours?
Oh, I'm stupid. It starts on stopped.
It starts on what?
It starts on the stopped state, so it never starts running. Okay, yeah, I guess that's a good reminder to always instantiate your enums if you're not like ordering them correctly. So timers will always start running. And let's redo everything that we did. Yep, okay. So now it should work because it's actually running.
Yep, it works.
You can see that it's going down here and Mario's gone. Cool. So that method works. The other method is to get a public reference to the timer. So we would get a public timer, and let's say timer. And inside start, you would do timer dot add listener. Timer dot on timer finish. So that's the event. You would add a listener there, and you would say something like this. Yeah, so this notation is kind of confusing. What it pretty much means is these empty parentheses are just saying that this Unity event does not invoke a certain type of data. Because something you can do with Unity events is you can put these hairpins here and you can say char, right? And now when I invoke it, I can give it a certain type of chart, like C, right?
Or even more interestingly, you can pass in a player state or something, or
Oh, yeah.
enum value.
Yeah, I actually do that for a different project, but for now, we don't really need to get that complex. But ultimately, just know that you can do it. It would invoke it with a character here, and you would be able to say, okay, well, it gives me a character, I'll call it E, and then I would call die with E if die did call a character.
You shouldn't, I don't think you need to lambda here. You can pass in die without the lambda. Just give it die without the parentheses. Just type in like the object die without the parentheses. Go back. Oh,
Wait.
yeah. Just remove the parentheses on die. That should work.
Oh, okay. Yeah, I guess the other way just shows the argument passing a little better. Yeah, so now what the statement does is it adds a listener to the event so that whenever that event is invoked, it does anything that's inside the argument for add listener. So once timer is invoked somewhere else, let's get rid of this part. So that's not functional anymore. Now that we have a listener on something else. Oh. Wait, did I get an error? Oh no. Oh, I didn't even give it the timer yet. Give it that timer. Cool. All right. And dead. Okay, yeah. So those are the two ways you can use Unity events. And that is also pretty much all I wanted to talk about. If anybody else has more questions, we're probably gonna stick around for a few minutes. We're probably not gonna stay for as long as we usually do. But if you have any like Unity questions or lingering questions about something else, we can probably answer them. But yeah, if you have to go or you don't have any questions, that's pretty much the end. So thanks for coming. Yo, Grant, do you think you're going to be able to use this information that you learned in gun game?
Grant's muted. He's I think he was in a conversation.
Oh,
I'm gonna post